The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. It was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everybody. I'm geologist Philip Ong here with Mr. Dane DuPont from HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, April 18th, 2024. We're glad to have our ASL interpreters back, Carrie and Daniel. Glad to have you back, Carrie. And our earthquakes are up a little bit, Dane. We'll have a little bit more to talk about as far as that, a little bit more interesting. And otherwise, we'll also touch base on the volcano awareness presentation from Mike Zoller on mapping, all the different kinds of mapping done on Kilauea and Mauna Loa over the years here. How are you today? And yeah, how you been?
Doing good. You know, just running around, trying to get a bunch of stuff done. Interesting to come back and see a little bit of more activity up there at the summit. So yeah, interested to hear your update and also talk a little bit about what we got going on Saturday, maybe at the end.
Yeah. Okay. Yeah. Sounds good. Yeah. So if you've never joined us before, at HVERI, our mission is to improve disaster preparedness response through volcano education and network building. So times like this, when there's not as much activity above ground, is when we're doing all the networking, all the preparation, all the planning, all of that stuff that allows us to better serve our communities when an eruption actually does occur. Yeah, or in this case, also some other disasters as well. We're trying to broaden our support here a little bit.
Yep, it's an all year round thing, just to be ready for the next disaster when it comes.
Yeah, the volcano is always always got something to talk about, but there's always work to do as well on a back end for a nonprofit. So just thought I would just share that. And anything else you want to add before we get into it here, Dane, today?
I don't think so. If anybody has any comments or questions, go ahead and drop them in the chat. And I think we'll try and do a midway point again on any questions that are relevant to current activity. And then if you got questions about what Mike Zauler talks about at the end segment, we can talk about it afterwards.
All right, sounds good. Yeah, thanks for leading that discussion in the chat. And thanks to Lou in the back end as well for helping us out there too. All right, let's transition our screen here and get ready for our summary. So in our Hawaiian volcano summary this week, earthquakes on Kilauea doubled over the past week. They're still at fairly low values overall, but higher than they've been for much of the previous part of the month here. The earthquakes are concentrated in the areas beneath the summit and South Caldera. Here is the last week of earthquakes plotted by depth, colored by depth. So the yellow ones are the ones that are slightly deeper under the caldera, part of the feeder system up into the volcano. And in the shallower regions, they're really concentrating in the South Caldera area right in here, and a little bit into the Southwest Rift Connector as well. But really the nexus of buildup seems to be right in here in the South Caldera. There's nothing alarming yet. There's no buildup to any imminent eruption, but it is interesting to note this uptick in activity beneath the central and southern caldera. If we look at the ground tilt at Sand Hill, we can see that over the last month, we're approaching 50 microradians of ground tilt, which is a massive amount. And so we're really seeing magma build up in that area, even as we continue to see GPS and other signals suggesting magma is going into the Southwest Rift, possibly all the way down as the whole south flank continues to move and accommodate magma there. So lots of magma coming in, filling into the Southwest Rift, building up underneath the South Caldera and quaking through the pipe and network of conduits up to the summit. That's the summary for Kilauea. And on Mauna Loa, the story has been pretty quiet. If we look back at the earthquake rates and depths over the past year, the highest peak of activity was in late October, early November 2023. And since then, it's been fairly quiet. We're at low levels here at the right end of this graph. If we look at that similar data in depth versus time over the last year as well, we can see that that big spike of earthquakes corresponds to a much deeper set of events. And actually, it propagated from deep all the way up into the shallow parts of the volcano. And that's the biggest upwards migration we've seen following the 2022 eruption. This plot goes back a year. So we're catching the onset of those deep earthquakes less than 5 months after the eruption ended. You can see there's been some quiet, some buildup of those events, then one upward migration, and then it's been fairly quiet apart from a couple of pulses, one that was at the end of last year, and the most recent one was just last month. And so here we are at the right end of this graph in April, and it looks like right now we're back in one of these pauses of deep events, and Mauna Loa is settling more quietly at the surface still. So that's our Hawaiian volcano summary for the week. And with that, we'll move to our volcanic hazard summary, which we'll once again take from the national park. We have an update from the VOG mapping project that we can expect their updates back online in May. So we'll show them when they're available again. For now, we'll use a national park. Their sensors around the summit are all in the green. And if we look at the charts that go back over the last 24 hours, we can see that it's been in the green. Most stations, apart from if we look at Kahuku, something's going on over there. But it's hard to believe this is actually from the volcano. So we'll have to follow up and inquire what's going on there. And everything else is in the green everywhere else, right? And in fact, the stations closest to the volcano are not showing that signal, which is why I can fairly confidently say that there's not appear to be volcanic there. So that's the volcanic hazard. That's really what all there is the gas is coming out from the volcano. Background level degassing at this point is about 100 tons per day, as we'll see shortly. So let's come to our Kilauea observations. And for this, we'll just take a quick peek into the live camera from USGS into Halemaumau. There's a passive degassing mineral buildup around those gas vents that surround the central plug that was the original cap of the very deep lava lake when it was deep in the crater, and has since risen through a series of 5 eruptions over the last 5 years. So there it is, passive degassing, and we'll move on to our monitoring on Kilauea. And we'll check in on the USGS weekly update released this past Tuesday. So here is what they say. Rates of seismic activity increased beneath the summit over the past week. The seismicity coupled with low rates of deformation indicate that magma continues to accumulate beneath the summit and the South Caldera regions, and also beneath the lower southwest rift zone. There are currently no signs of imminent eruptions, but monitoring continues. So we're seeing more prominently the statement that activity continues beneath the lower southwest rift zone in the update here. That's a little bit more nuanced than we've seen in other updates. They do note here the rates of seismic activity beneath Kilauea summit doubled over the past week. And overall, there have been low counts, but brief sequences of elevated activity have occurred several times over the past week. They note the 2 regions of increased activity being beneath Kilauea summit, deeper earthquakes about 8 miles down, and shallow earthquakes about 1.5 miles down under that South Caldera region. Magnitudes are small, usually at or below magnitude 1, sometimes too small to detect, and there's still long-term inflation across the summit. Here's our SO2 value, 96 tons per day on April 8th was the most recent measurement, and that's the background, but even that background value will exceed our environmental regulations if it were a factory, so it certainly is something to be concerned about if you happen to be in the downwind direction. So that's why we check in the national park monitors. It's all looking pretty good. If the winds change, sometimes they do, then, or if you're sensitive and you're in a nearby area, then certainly take your precautions and follow the park guidance. So they're noting here in the rift zone observations, seismicity continues beneath the Kauai fault zone and into the lower southwest rift zone. Ground deformation recorded by GPS instruments shows ongoing deformation across this region, a sign that magma continues to migrate down rift. And so this is something we've been talking about for weeks and weeks and weeks now. We're watching the GPS signals down there. They're still moving ever since January, and it is now noted in the update as well. No unusual activity has been noted along the East Rift Zone. For those of you who are residents of the East Rift Zone, that can be a reassurance there. So they're issuing prognosis. The magma system continues to recharge following the intrusion. That's really the long and short of it. That's where we are. We've been seeing this long-term slow buildup. It seems to have hit maybe second gear now. We're not anywhere near that levels of activity we've seen prior to the intrusion in January or the eruptions last year and the year before that. So it's a step up, but still nothing alarming. Just something for us to note here since we're close followers of this. Looking at the USGS graphs, we come to the top here. Over the last week, the tilt meter at Uekuhuna did go out on Monday. And so you see this very straight line to where it seemed to have picked back up earlier in the day today and seemed to have come back online. Overall, not a whole lot of difference start to finish here that we can tell, presuming this is calibrated. And the earthquakes are fairly flat across the week, which is what you'd expect for that kind of signal too. But we're a little bit too zoomed in to see the pattern as we saw at the top of our update. We'll look at that month time frame here in just a few seconds. But first, our depth versus time over the last week. So this is the shallow band of earthquakes that has come in over the last week, right there in the orange. And earlier in the week, these yellow ones were the deeper ones underneath the summit. And so we'll show you guys some cross sections that maybe show how the magma could be feeding in, from as far down as the Bahala region up to this region underneath Kilauea summit, up into the shallow parts of Kilauea, and they seem to be going off in a little bit of a sequence there. Although the deeper earthquakes are still ongoing, and we've never, I can't say never, but it's hard to link directly that the earthquakes here might have led to the ones up here, but it does certainly appear that way in this plot right here, right? The deep ones coming in first, leading to the shallow ones increasing thereafter. So yeah, that's an interesting note there. And on the map, as we said, they seem offset in space a little bit as well too. Deep events in Bahala are still ongoing over here. There's still some activity happening in the lower southwest rift zone there, but really sparse. Perhaps just as important is that there are shallow events and even some deeper events happening on this south flank section just oceanward. And if this thing keeps moving, that might be what actually opens this pathway in here for magma to keep draining down from the summit. And if the crack is getting wider and wider, then the magma can't really pressurize that much, and it probably can't cause that many earthquakes. So it might all go hand in hand here, and this is something to watch, not just the earthquakes in the lower part, but this offshore section as well that is mobile, can make some space in there. So in cross section, that's what the deep Bahala earthquakes look like. Let's zoom this in so it's a little bigger on the screen here. And there's a deep Bahala vents right over there. Potentially there's a pathway that leads up in this direction, and then from there up into the volcano. So there's our yellows right directly underneath the caldera. And then we have straddling the caldera and the south caldera areas over here. A little bit of the upper southwest rift connector in here, and then the lower southwest rift zone. That's the entire system as we see it here. Pretty interesting to see that fill out. We noticed those deep earthquakes coming in a few weeks ago, and now they're really filling in down there. So over the last month, it's more obvious how much the ground has been inflating. We're at -8-ish down here on the left, and ending up here at +6 or 7, so 15 microradians or so, measured from Uekahuna, with a little bit of data missing right through here. And deflation-inflation cycles superimposed upon it, suggesting there's still magma overturning within the reservoir in that shallow part under Halema'uma'u, which is what we believe might lead to these signals. In the south Caldera region, that's this green line from the Sand Hill Station. We talked about that in our summary. Massive amount of inflation. If this was all happening all at one go, then we'd say for sure there was cause for an eruption. This just happens to be really dragged out. So it's really bulging up there. But the volcano is able to stretch and accommodate that without actually breaking. And that's partly because how wiggly everything is and how mobile those cracks have been ever since the 2018 collapse and the refilling. And it's almost like an accordion refilling, and it's not quite to where it can actually needs to tear open in that area, given the south flank movement happening recently there. So there is that depth versus time for the last month. Here we see when we first saw those deep earthquakes coming in, beginning of April, and here is their intensification over the last week there. The shallow regions are harder to tell. The background is still pretty dense in its plotting here, and it becomes even more so in the recent week here when it picks up in the shallow South Caldera area. There is that easiest to see graph, which is why we chose it for the summary, showing that background level. We saw that first little peak, little hint of it starting back up a little bit more, and here comes. And our takeaway last week was if we see these levels of earthquakes sustained for a while, then we'll know we've reached a new stage of this buildup. And if not, we're still cycling through that first gear where we're just revving it up and revving it up. But as we can see here, we've actually have maintained for the last week. And so that is a increase in the phase and a shift up in the process towards whatever comes next, whether it's an intrusion or eruption, and however long that may take. So over the last year on Kilauea, there is that intrusion end of January, beginning of February on a southwest rift. And we've really been recovering ever since then. You see it really tailed off very quickly into March. And now we've popped back up, and likely we're going to see this come up a little higher here on the right end of this graph. These are earthquakes per week now. And over the last 5 years, earthquakes per month, you see that in April thus far, we've already almost nearly matched all of the events in March. So we'll clearly exceed this this bar will come up somewhere, who knows how far up in there by the end of the month. GPS, Kilauea is still expanding north and south across Caldera, as seen here, consistent with the long-term inflation. And down at Pu'o'o, the long-term pattern is still of contraction. There is a little bit more noise in the data here recently, but as you can see, this has happened before other times, and we really just have to wait to see what actually settles out of this. And some other GPS stations are showing some more noise as well, because there's been a lot of cloud cover and weather in Hawaii over the last few weeks. So we'll wait and see what happens with that. But without any other corroborating signal, there's really no cause for concern down here in this pool area for now. So those are the monitoring signals. And we'll switch over to the earthquakes and share a little bit more about the earthquakes. And this is all the events over the past week. The largest events were 3.2 deep under Pahala, 20 miles down, 2.8, 20 miles down. Whoop, that was not the right button. And we have some shallower ones, 2.7 on the west flank of Mauna Loa there, 2.7, 2.6, kind of spread all across the island. So let's zoom into the Kilauea region, since that's what we've been talking about most recently here. And within this map area, now the largest event is a 2.5 that occurred on the 16th, a couple of days ago. And there was one today, 2.1, and we see the one in red here is a 1.9 that occurred within the last hour here. So you really can see the clustering here in South Caldera area, a little bit here off to the south along this quiet fault zone, but you can imagine that this whole thing is part of this mobile connection to the south flank. So there's the ribs of the accordion, in the farthest upslope part of it that you can see right through here. So not quite sure, exactly where the magma is moving through. It could be moving through areas without those earthquakes, but you're seeing earthquakes concentrating mostly here. You see them activating here along a quiet junction, and then a few much more sparsely down here towards the southwest, right? And when we get to the southwest area here, it's much harder to tell what's going on. This is where I like to switch to our USGS HVO website map, where we can color them by depth. So on this earthquake map colored by depth, now we can see that the southwest rift area has this overlap of both deep earthquakes and shallow ones. And in fact, all across the island are quite a few of these blue and purple deep events. You can see as part of the background, but concentrated underneath Pahala, where interestingly, they seem to be forming this donut shape here over the last month, with one cluster more towards the Mauna Loa side and one cluster that's more like this upturned V pointing at Kilauea. Right, and another one here off to the south towards Loihi as well. Right? It's interesting to see that developing over time, propagating outwards from the center here. So let's plot the cross section that I have marked here. I've got A in the southwest, I've got B in the northeast, and let's view the plots here. And I've hacked my browser once again to show us a few more information. So this is the time depth, similar to what we saw on the USGS plot for the last month. And so there you see that original deep earthquake and that more recent cluster within the last week. And you see here from this why we use that USGS site that actually picks up a lot of the smaller events, those less than magnitude ones that don't make it all the way to the more public site where you can query each individual earthquake, right, and look at its data. More steady in a deeper Pahala zone over there. Okay, here's our cross section: A southwest, B in the northeast over here. So there is a deep Pahala vents right there. There is that suggestion of an inclination moving to the east there that might lead something like that, or maybe it goes more like this and then up. Who knows? Big unknown, right? There seems to be also some pathway that comes up this way. So if so, you're seeing like a joining of magmas, right? But it seems to be activating this deeper region here. That's that 8 mile down region, all the way up to maybe 3 miles below the summit right there. Comes at the shallow, and there is that wing off to the southwest, and then a further southwest rift and southwest rift flank earthquakes seen off to the side over here. And it's these deep ones on that southwest rift flank that allow that rift to open and more magma to be more voluminously accommodated. So more magma can fit in there if it moves deeper, if the stack moves from deeper. At the very bottom here, over the last month, we have our earthquake rates. So you see they've been occurring. This is time going this way for the last month and just how many events altogether. So what we're looking at is how steep is a line. So it's going at a moderate rate, slightly slows, moderate slows, a little slow. It's coming, it's picking up a little bit, slows a little bit, picking up a little bit. Now it's coming a little more straight up. And so that's where we are now, where it seems to have come up a little bit more as far as how many events are occurring. And that's showing that it's reaching some pressure threshold where the quakes are kicking in. All right, so that's looking at that entire section there. So what I want to do is filter it a little bit. So let's take out those deepest events from there. And at the same time, let's go back to the last 2 weeks. And let's come back and let's re-examine our plot. Well, this seems like I did it on the wrong order. So the last 2 weeks, and now let's take out those deep ones. All right, look at our plot. So depth versus time for the last 2 weeks, shallow events and little clusters, and here are the bigger flurry of them recently. And as time moves on, there is when these deep events kicked in right through there, right? So notable that there were earthquakes happening in the shallow regions before that, but it's after the deep events that they actually kick up a notch in their counts. So a little more zoomed in here from southwest to northeast. There's a deeper conduit, and the cluster that includes both a South Caldera and a Southwest Rift connector, and further over that way to the Southwest Rift. And we're zooming in on just the earthquakes in that one region and excluding the deep ones. And so without the deep earthquakes, kind of keeping things steady ongoing, you see the shallow regions have had much more of a start and stop and start and stop and start and stop pattern. And more recently, coming up quite a lot, a little gap, but still coming up as we speak now. So let me put this in a little closer. Let's put A over here and put B over here. And let me now filter out all but the shallower events. And let's look at it now. Not very interesting in a time depth, but here is a cross section that's really interesting from the southwest and northeast. Right? And let's see if this gets bigger. Yeah, there it is. So negative 0.6 miles. That means it's above sea level. This is below sea level. So sea level would be right in here somewhere, right where it changes from the dark red to the bright red. The caldera is underneath this region right in here. If I left the yellow earthquakes on, that's where they line up. And so here you see in cross-section how these earthquakes are distributed underground. And quite obviously, there's one big chunk of them right in here, and that's the South Caldera area right there. This is a Southwest Rift connector over here. Area, so it's certainly active, but it's not nearly as active, not nearly as dense and clustered as you see right beneath that South Caldera area. So right now, that seems to be where the magma is building the most pressure, even as it flows through there and out the Southwest Rift connector down to the lower part of the Southwest Rift. It seems to be backing up enough to build pressure in that area. And so that's clearly one of the signs towards the next event, intrusion eruption that needs to happen. But we're not quite there yet. We expect to see a lot more of this. This is the first sign of it flaring up here. Okay, so that's some cross-section insight. And just with those shallow events, there is the earthquake rates again. Let's zoom back out so you can see. And yeah, start, stop. And here we go, a lot more. This is the last week of it really skying upwards. So let's show you one last thing with the earthquakes before we take our break, wrap up the Mauna Loa and take our break here. This is here, the events. Well, what have I got going on here? What I want to show you is that this is the website I'm using from Earthscope Consortium, IRIS interactive earthquake browser, where you can come and select different time ranges and plot them and even animate the earthquakes here. So what I wanted to show you first is the events just from October to March, October last year to March this year. This is going to catch this big pulse of the intrusion, as well as how far this goes down the southwest rift. And you also see here it's activating this upper east rift connector as well. So let me play this once through here, and we're going through a bunch of months, but this is a build up to that big intrusionary pulse. And we're in January right now, and we're about to hit February now. There is the pulse. And so after the pulse comes through, there's a little bit more background activity, but it's fairly quiet overall. So in comparison to that, here's what March until now looks like, right? Not nearly as many events. They start coming in the South Caldera. You see them activating the Southwest Rift connector, all the way down to the lower Southwest Rift, building up a little bit more in the upper reaches. And then here we come. The last flurry in the last week is right there at the end. Kind of hard to pick out, but it was right there in that South Caldera area. So that's a little context. They're picking up, but not nearly as much as we've seen in January and February. So that is Kilauea today. We will check in on Mauna Loa as well. The tilt there is not moving a whole lot in significant ways. Earthquakes for the last week have been very sparse and only in shallower depths. And over the last month, we're still seeing some wiggles in the tilt that are a little bit hard to explain, but when we look at other signals, it does seem like that all that southwest rift of Mount Kilauea is still affecting Mauna Loa in some way. And so that's the easiest thing to attribute this to, but there could be other reasons as well that are just harder to figure out and can't really make a good interpretation for you guys without some input from the USGS perhaps here. Over the last month, depth versus time, a couple of deep events coming in, but overall pretty quiet for all of April. And the rates are still quite low in earthquakes per day. The maximum for the last month has been 4 earthquakes in that summit region. So really, really low overall. There's a context we shared in our summary. Over the last 5 years, similarly, you can see we're quite a bit down here. All right, so let me scroll past this earthquakes and come to the GPS, where we can see that Mauna Loa does still seem to be extending from north to south across its caldera as well, with some little variations. That might be these wiggles of perhaps, could be noise in the data, it could be influence of Kilauea southwest rift. Wait and see perhaps. And what's interesting is that in some areas like this, you see this upward component at Mauna Loa. It does appear that even if it could be noise, that the data seems to be trending downwards perhaps, like maybe the summit might be actually dropping a little bit, which would be some relief of pressure due to that adjustment of the south flank. And like I said, it's hard to really know how true that is until we wait more time and see if there's corrections to the data. Over the last 5 years, we can see that we're still recovering from that 2022 eruption, still coming upwards, extending north and south, and coming upwards down here. But I thought I could show a little bit more. We have 2-year GPS stations all across Mauna Loa as well, and without getting lost in the weeds too much, there are some stations. Here's one at 12,570 feet. And its up signal, this also seems to be showing a little bit of a downward trend, so maybe there is something going on there. And yeah, there's a lot of wiggles, a lot of places, not to get too lost in the weeds here. Let me go all the way down to the northeast flank and the south flank at Ainapo here. So this is Ainapo at 5,000 feet, just west of Kilauea, pretty close with southwest rift. So this right here is showing how it was able to move to the west and to the north during the eruption of Mauna Loa when pressure was being relieved. Since then, it's been building back up. But now, since October, we're seeing a series of turnaround where now this station is overall moving back to the west, right, back towards Mauna Loa summit. So either Mauna Loa summit is sagging and or Kilauea is pushing it that direction from the other side, since this is in between both stations there. Right, so that's an interesting note there, and you can see that there was a big drop during that January intrusionary event, and we're seeing another one happening now. And so without really knowing what's happening at the tilt, we can say that there seem to be localized movements on Mauna Loa's flank that perhaps link into what's happening at Kilauea. So that's Mauna Loa, and we will touch in on Volcano Watch here next. In today's article on Volcano Watch, magnetics, magma, and monitoring. New technology for old questions, right? So we're looking at magnetism as a way to monitor the volcano, is what it comes down to here. And Volcano Watch is posted online at our usual places if you'd like to check it out in full. I'll just highlight a little bit here. They've been studying magnetism for a long time, but it's really hard to pick out what matters because the signals caused by magma are much smaller than those all around us, whether they're caused by equipment around us, by energy coming from the sun, by any of the ambient stuff around. So let me get into it here, right? They've been studying this at Kilauea back, and this picture comes from 1950. So you can see they've been studying this for a while. And let's see here, motions of the Earth outer core. I left that out as far as potential influence of the magnetic field as well, right? So the magnetism on Earth is changing all the time. The magnetic pole wanders around, the intensity increases and decreases. And so on top of all that, we're looking for micro variations of magnetism due to the volcanic activity. And you might say, like, well, that sounds like it's like a shot in the dark. Is it really worth it to do all that? And so to jump to the conclusion of that here, INGV, which is Italy's National Institute of Geophysics and Volcanology, so the Italy version of the USGS HVO, has been monitoring Mount Etna for over 20 years with magnetism. Yeah, Mount Etna in Sicily there, in southern Italy. So they have 8 stations and a reference station. They measure every 5 seconds. And across this 20-year data source, they note that changes in magnetism can often be attributed to shallow magmatic intrusions. Right? So that's really interesting. They're actually are seeing a signal. But the way that they do that is by having one station that's near the magma changes and one station that's nearby but far from the magma sources, which allow you to then see what the influence and what the variation of the background is. So whatever's happening with the sun, whatever's happening with electrical activity nearby you, whatever's happening with the core of the Earth will affect those places all equally, but the magma will only affect the places near those stations. And so you can subtract one signal from the other and have a clean magma signal left over. So they don't have these at Kilauea yet, but they're looking at what works elsewhere in the world, which is assuring to note that, right? So they do know all the history of USGS trying this in the 50s, trying it in the 70s. And what's happened is there has been a new development in technology. And so they have now what they call quantum-based sensors, right, that are actually able to detect magnetism in a better way. So they're dramatically smaller, they take lower power, and are much easy to install. So these quantum-based magnetometers are what they're talking about. And since I had to just know a little bit more about that, I just did a quick search here and I came up with this page here that just highlights what actually is going on here. Right? Why are they calling this quantum? And they basically say that quantum magnetometers take advantage of the spin of subatomic particles, and through polarization, the particles are caused to precess in the Earth's ambient field. They can then translate that frequency of precession into magnetism. That's what's going on there. So that is Volcano Watch for this week. I thought we should also just very quickly mention that we still are in Tsunami Awareness Month here in Hawaii. And if you were following along with our updates last week, this 3-stage process, towards the end of the month, we want to make sure you have identified your safe evacuation plans and are sharing, comparing your plans with your family, friends, and neighbors. And so just a little check-in on that. We'll turn to our community now. And really briefly here, the national park construction is still ongoing at all the sites recently mentioned. That's Uekahuna, the visitor center, the entrance station, and the tree molds area off Mauna Loa Road. So all around, lots of construction ongoing in the park. And that is it for now. I'll pass it to Dane. We have some other maybe community things to talk about, but I'll give it to you here, and maybe you can mention what you like at this point.
Yeah, I think we'll go ahead and thank everybody for being here. First and foremost, we rely on viewers like you to get the information out there. To the likes, the shares, the subscriptions, all that stuff really does help. You can also help us more directly with a donation. We take those through hveri.org/donate. You'll see it on the screen there. Right. But yeah, I'd really like to thank everybody that tuned in today, especially in these days when not a whole lot is happening. We had the subtle changes, and that's where we really rely on the steady regulars to show up, and we appreciate you.
So community events, Dane. Something's going on this weekend.
Yeah, so we have the Youth Jam in Pahoa that's being put on by Minipa'a, and that's at the, I believe it's in Pahoa at the community center. I think it's at the park, the Billy Kanoe Park, actually. Sorry, did not have this up right in front of me, ready to go at this point. But yeah, it runs from 10 a.m. to I believe 3 p.m. and it's a bunch of people are going to be there. The space is going to be there. The Seaview acrobats and jugglers and all kinds of stuff for the kids, for the youth. It's a clean event, right? And it's for the betterment of the community and empowering the younger generation. It's really fun event to be able to go see. There you go. Brought on Cuz. Yeah, Minipa'a putting this on. Great people over there, and a whole bunch of support. You know, those guys do amazing work, and we'll be there as well. We'll be setting up a table, and you can come say hi and talk some story with us.
Yeah, thanks, Dane. And are we gonna share about the survey today as well?
I don't think we're ready.
You don't think you're ready? Well,
I don't know. I don't have any. I didn't hear much about it from him.
Okay.
I don't think he's ready for the survey.
All right. Well, we were hoping to promote a survey that we were contacted by a student here. So maybe watch our feeds. We'll post it when we get it, and we'll just not include it as part of our update today. We'll just make sure it's posted to our different feeds here. Right. So as usual, we try to make sure that we involve all the community. We do have a new initiative to involve more youth as well. So we're just trying to make sure that we're supportive as much as we can, and also that we benefit our community, because good ideas coming up from the youth, and to help increase our awareness, preparation, our response, all of that. It's going to take all younger people than us long term to keep this going. So we're stoked to have that ongoing there. Okay, yep. So other thank yous you want to say? I can put on the thank you screen here.
Yeah, go ahead and put on the thank yous for us. We'd just like to thank mainly our two big sponsors right now, the Kilauea Recovery Grant and the Puna Strong Grant, both through the County of Hawaii. And we'd also like to thank Hawaii Community Foundation for all their help that they provided along our way. Right, just throw that one in there too. Whole bunch of people that have really got us to this point. Right, we put in a lot of effort, but there's a whole bunch of people behind the scenes that really help us to be able to do this work, and we want to just appreciate them as well. All right,
yeah, thanks, Tim.
Yeah, no, just again, we don't have a donation drive going or anything like that right now, but every little bit helps, and those are tax deductible donations. Make them on the website hveri.org/donate.
We have some questions to get through in our halfway point now before we get into our mapping presentation.
I do not believe there are any questions, except for one. It's Michael asked, what does HVERI stand for? Hawaiian Volcano Education and Resilience Institute. And that's the only question I see in there. So I think we can
All right.
proceed. And if you guys do have questions, go ahead and drop them in and we'll get to them at the end.
Sounds good. Okay, so we'll transition to our volcano awareness presentation. And as we mentioned, we are recapping, here it is, Mike Zeller, USGS HVERI and geospatial analyst.
Before we get in, we did get a question. Do we want to just do it real quick since we were right here type of thing? And okay. Question: the cracks that appeared on the Kona airport pavement recently, is that common phenomenon that occurs due to stresses from aircraft landing or seismic earthquake related? Or a combination of the two?
The Kona airport, yeah. The Kona airport. So for those who don't know, the Kona airport has had, I think, 3 closures this year due to cracks in the runway.
Right.
And yeah, I don't believe it's got anything to do with seismic activity. I think it's probably more just the maintenance of their tarmac. There is background earthquakes that happen there, but nothing huge that would have, really affected that area more than anywhere else. There's a lot of, the whole island is in constant motion, right? It is settling in certain areas. The land expands and contracts, so there's all of that happens all the time. And so I think it's more to do with that than it is to do with the earthquakes. But if you were driving around all the roads of Hawaii, you might think differently, because there's a lot of maintenance that needs to be done, island wide, really. So
don't even mention the bridges. Don't mention the bridges.
That's just part of the issues that we're dealing with out here. Yeah, the bridges thankfully have been being seismically retrofitted for. It's been taking a long time, but at least they're doing it. Done a lot of it. So
all right. Yeah. Well, we can go ahead and proceed though with Mike Zeller's talk. Thanks for taking that question.
All right. So our volcano awareness month presentation once again from Mike Zeller. I'll switch our screen over here and we'll let Carrie take it for us here. And let's see here. Mike Zeller.
My name is Mike Zoller. I'm a geologist and GIS analyst at the USGS Hawaiian Volcano Observatory. I'm going to talk a little bit about what goes on behind the scenes when we're doing what's arguably our most important job, which is just getting information out about where the lava flows are and where they're going. We use a lot of different techniques to get that information, to collect that information and then disseminate it to the public and get it out, to emergency managers and you folks, so that the people of the island can make informed decisions about evacuations, where to go, and just in terms of planning and where we want to live and how we want to develop the island, because obviously the hazards are very different depending on where you live. When the Pu'u'o eruption started on the Kilauea East Rift Zone, maybe 20 kilometers uprift of here, back in those days, most of the mapping was done via overflights and helicopters, and then the geologists would come back to the office and sketch what they saw onto these topographic base maps. And they might also take them up in the helicopter with them and just eye different features in that topographic map, like different craters, different little pu'us that they see out there, and just sketch like dead reckoning, like their best guess of like where the edges of those lava flows were relative to those features. And by and large, they were really good at it. Like looking back at a lot of this data now with like modern satellite imagery, they were like right on the money. They did an excellent job, but this was a very time-consuming process. By the end of the Pu'u'o eruption, this map here is from December 2017, when some of the lava flows were still trickling down onto the coastal plain. Really, the data for the eruption maps was coming from 3 sources. Helicopter overflights that were doing thermal maps of the flows, and the expert on that is my colleague Matt Patrick, who would carry this thermal camera and like film the lava flow from the helicopter, then georeference all the images and make this like mosaic of all of them that they could then sketch in like the areas that were new flows from that thermal map. Ground mapping is just walking along the edges of lava flows with the GPS. Very accurate, but very time consuming. And then the third thing is satellite mapping, and that's something that we still use a lot today. Actually, we still use a lot of number 1 and number 3 today. So this is an example of one of those thermal mosaics that Matt Patrick would have made. And you can see the hot spots in brighter red, and then the colder, older parts of the flows in the blue colors. And then obviously all the gray is just older Pu'u'o flows. So this is focusing on the episode 61G vent that was erupted just for the last couple of years of the eruption. And so those hotspots that you see here, by and large, correspond with the mapped red, like bright red polygons on this eruption map that you see here. So that second method, the ground mapping, as I explained, was very time consuming, but we got really accurate data. And it looked a lot like this, just somebody with a backpack on, hiking along the edge of the flows. That was probably arguably the most fun way to get out there and just experience the lava flow up close and personal and get some really accurate data out of it. But as I'll explain in a moment here, that proved to be a challenge with some of the eruptions that we've had the last couple of years. We weren't able to really do this very much. Now for the satellite mapping, the reason why this is done by folks on the mainland is that it's mostly using classified military satellite imagery. So there's this group in the USGS called the National Civil Applications Center, or NCAC, and they're based in Reston, Virginia, and they hold security clearances to access like the high-grade military sat images that none of us are allowed to see. They'll hand us like these polygons that have been digitized from the military satellite images, and we just have to trust them. And they're really good at it. They do eruptions all over the world. They've done our eruptions here for about 10 years, dating back into the Pu'u'o era. So they've become very good at it, but it often does require a little bit of review on our end. Sometimes they might like mistake a wildfire for a lava flow or something, so that's a confusion that we want to remove from the process. But their turnaround is pretty quick too. They can usually get their data from the satellite to our hands in about 6 hours if we're in like a good routine of working through like a consistent eruption. Although it can take a little bit more time to spin up this effort at the beginning of eruption, because I think they have to retask the satellites to like view different areas. I don't know many specifics because we're not allowed to know too much more than that. So that was the Pu'u'o era, and then, as many of you know, we transitioned into the Lower East Rift Zone eruption in May 2018 when Pu'u'o collapsed and the intrusion of magma came underground into the Leilani Estates area, and this was a whole new ballgame. Now we have all these new aerial tools that we're trying to implement, and that proved a little tricky because here's Fissure 1 on May 3rd, the very beginning of the eruption. Now, how are you going to walk around the edges of this flow with a GPS instrument? It's not going to happen. That's dense jungle down there in the Leilani. We tried to do thermal mapping, but it was difficult with all the trees right around the edge of the flows. You don't get like defined edges. And eventually, we had to resort to some backup options, which was essentially what you're seeing here. So we have a point here for a three-dimensional lava fissure. It's not great, but we can make do with this, and it's enough to get some sort of information out to the public about where these lava flows are affecting the Leilani community, and as a result of data like this coming in, we were able to produce maps like we did in the first few days of the eruptions with just points marking the eruptive fissures. As time went on and our friends at the NCAC office in Virginia started to get their operations spun up for the Lower East Rift eruption, they did start sending us satellite data, and that was super useful and allowed us to get caught up on those early fissures and allowed us to track the progression of the flows as that eruption unfortunately expanded around the area. We did also rely a fair bit on drone mapping during the 2018 eruption, and early in the event we were relying a lot on the Hilo Spatial Data Analysis and Visualization Lab. Later in the eruption, we had a whole crew of USGS folks come out and start to assist with that mapping. These little sketches on here are the flight areas that they were able to cover, at least Ryan Peroy's group during that eruption. The drones are a little bit limited on their range. They can't quite get out to the full extent of that. And so most of the drone work during that eruption was focused on the fissures themselves, not the distal ends of the lava flow. Although there was a little bit of work up at done up at the Four Corners area where they were able to access some of the flows that were extending towards the vacation land subdivision at that time. After the 2018 eruption ended, we contracted a LiDAR survey. From that, we were able to get accurate elevation data of the flows and get like the ground surface change from before the eruption, and then thus the volume that was erupted. Up at the summit, we were able to model the collapse crater, which was shortly thereafter filled in by the water lake in 2019. This proved to be foundational for so much of the work that has come in succession in the past few years. Having this high resolution data allowed us to do extremely accurate measurements of the lava volume erupted up at the summit eruptions, and has allowed us to incorporate this updated topography both at the middle east rift zone and the lower east rift zone into our DEMs of the whole island, and to use that for flow model simulations, so that if an eruption happens in these areas again, we're not using the old topography to model the directions of those flows. We're using the new and the latest and greatest new stuff. And as I explained, that data, especially up at the summit, was really useful once we started having those summit eruptions. And when those first started, and this map is from the very beginning of the second summit eruption that started September 29th of 2021. In this case, I didn't even wait for like a helicopter overflight or anything to make this map. We had such good webcam views of the crater, and we had folks on the crater rim shooting vertical distances with a laser rangefinder down to the new surface of lava down there. We knew within like a vertical meter exactly the level that the lava was at. And just based on like drawing a contour line on that LiDAR digital elevation model that we got in 2019, we were able to get like the exact bounds of the lava flow on the crater floor, and get the exact volume that had been erupted. And also just like jotting in like the positions of the fissures, and that's kind of just triangulation from the webcams. Like, you know, looking at it from one angle, seeing that it's like, oh, it's just to the east side of that island that's there in the middle of the crater. And then looking at another view and seeing like, oh, it's actually a little bit more off the north end. So kind of just like pinpointing them in from that. And this is kind of like a rough and dirty way to do it at the very beginning of the eruption, get the information out there as quickly as possible. As the summit eruptions have progressed, we're able to dive into more analytical and more detailed methods. This is an example of a structure from motion model that we generated from the second Kilauea summit eruption, in this case in March of 2022. Structure from motion will fly around the crater in like an orbital flight path, whether it's in the helicopter or in this case with a drone, take a bunch of sequential images, we can merge them all together and create a three-dimensional model and an orthomosaic of the area, you know, depicting, you know, the colors as well. This is a slightly more accurate method. That surface is not always exactly flat. There is a little bit of relief to it, maybe as much as 10 meters or so, because the lava will often bulge on the side where it's coming into the lava lake from. So it's a little bit higher in that spot. And we can get a slightly more accurate depiction of that topography, the extent, and more accurate measurement of the volume from a model like this, and comparing to the previous ones that we've done. So we were doing these, whether it was from the helicopter or from the drone, maybe like once every week to 2 weeks during that eruption. That second eruption lasted over a year, and we got into a pretty good rhythm of doing them really routinely. Got a little bit more challenging with the last couple of summit eruptions, just because they were so short. We weren't able to spin up the drone and helicopter monitoring, helicopter mapping quite as much, and it was a little bit challenging with the wider geometry as well. A little bit far for the drone to cover, and also the helicopter, we couldn't fly on the downwind side. You know, we'd be clouded out in the gas, so we're kind of confined to those north and east sides of the crater that were upwind, and which is not as optimal for the viewing geometry, but we were able to make it work at least on a few occasions to get decent data. So this is an example of one of those digital elevation models that came out of those structure from motion surveys. And from this data, we're able to, of course, produce the accurate eruption maps with the statistics that, like you see here on the bottom, that a lot of people like to use to track the eruption. So we have, usually on these, we're providing a number for the crater floor, but there's usually a volume averaged level. It's not like the highest or the lowest point on the new lava. It's kind of just an average of the whole area from this eruption. And we're showing the rise, and that lava volume is a differencing of the model from this particular date versus the one from right before that eruption. So when an eruption ends, we get out there with our highest detail cameras and get like a really, really good model, because we know that we're going to need to tie in the further surveys to that non-eruptive model to get the difference in volume and difference in elevation. So that was the Kilauea summit, which proved to be a very, dare I say, easy eruption to map. You know, being confined there in the crater, Everything was kind of right there in front of us with the webcams, and for those of us visiting on the ground out there as geologists. Then we had another eruption in November of 2022 that you might have heard about up on Mauna Loa. We had vague views from our webcams, but it was very tricky to pinpoint. And further complicating matters, the weather was really, really poor that night. The summit was clouded in, and this was actually one of only a few frames that the thermal webcam was able to see the lava, because the clouds just came right back in and clouded over and blocked the views. And as an example of that, this is the only satellite image that I'm going to show today, because this is not one of the classified ones. And so this is what our analysts back on the mainland were trying to work with in delineating these flows. And so you see some red peeking out through the clouds there, but that's actually just the lava channels. We're trying to get the whole extent of the flows that's been inundated. So this wasn't super helpful at the time. That first full day of the eruption, starting with the morning of November 28th, 2022, we were able to get up with our helicopter observations, which we've relied on for so long here at HVO. I was lucky enough to be on that very first overflight, and so I pulled out my phone on the helicopter, started jotting in lines just for the eruptive fissures, just based on like my position in the helicopter, looking over at this eruptive fissure. It's starting at this one pu'u, it's ending at this other kipuka, like maybe a kilometer down the rift zone, and just jotting these lines in, and then plotting the flow front points as well, based on sometimes laser rangefinder measurements, or if we were able to like fly right over the front of it, I was able to like drop a point in the map. And so I was able to like get on the radio and just say like, hey folks, like back at HVO in the office, like open the map up, like the data's there. And so within an hour, they were already running flow model simulations to see where the flows might come down slope from that. Even from like those early hours of the eruption, it was clear that it might be going towards Saddle Road. Fortunately, it stopped before it got there, but we could kind of see that was the direction that the eruption was going to take, just based on that initial data. As long as we get where the eruptive fissure is, where the lava is coming out of the ground, we can run those topographic simulations to see where the fluid is going to travel down slope. From that data that was collected up in the helicopter, we were able to produce the first map of the eruption that afternoon of November 28th, showing just the fissure, the flow front points. And then on this map, I put in these labels up at the summit and like on this like upper southwest flank, and then on the upper part of the northeast rift zone, just saying like, we know there were fissures here. Like we flew by them in the helicopter, we could see them, but we only had partial views. Like it was not going to be possible to go in and digitize those whole bounds in the time that we needed to turn around this map. As time went on, we did eventually backfill some of that data, mostly using satellite images. But as things started to encroach on Saddle Road, we also started to resort to some other novel techniques, which is pretty simple, just shooting distances using our laser rangefinder. We use a Vector 23 laser rangefinder that can shoot distances up to like 40 kilometers. So the flow to Saddle Road, I think, was 3 kilometers at the closest, so it was well within range. That's only providing us with a point for the front. We want a little bit more comprehensive data, showing the full bounds of the flow. And so while our satellite analysts were still catching up because the weather was still bad for the first couple days of the eruption, another novel technique that we developed was just webcam mapping of the flows. You look at this in the dark and you have no reference points. It's like, where is this thing in space? But fortunately, because that camera is fixed, we know that the daytime views are exactly the same extent as what you're seeing there. And so we can just jot in a line for where the flow front is on the dark image, transpose it onto the daytime image, and then by comparing to other features that are visible in that daytime webcam image, we can sketch it in relative to them. So in this image, take note, there's very faint, there's a little lighter colored kipuka of extremely old lava, maybe like 4,000 to 5,000 years, right off the tip of that flow. That is this right here. So looking at this image on the pixel level and picking out extremely fine scale features like that in the webcam image, this is not as accurate as our other methods, but I think we were probably within like 100 to 200 meters on the ground in terms of accuracy of the position of this flow front. And when there's no other data available, this is what we work with. And I think we did pretty well with this method during Mauna Loa, and if we have to rely on it again, then I think it's well refined and it's reasonably accurate at this point. So this is an example of the map that came out of that particular effort to do that webcam mapping. So you actually see a combination here of, this is the red polygon is what we sketched in from the webcam image, and then we actually put an extra dot on there because the flow had moved a little bit in the time that it took to do that work, and somebody at the Saddle Roads shot a measurement with the laser rangefinder. So we showed like an extra point to just say like, okay, it moved like another couple hundred meters closer to the road. But right at the end of the eruption, we started doing something even more exciting with the mobile app that we were using to transmit this geospatial data back to the office. Because we realized that we have a good cell service up there. We can leverage this even better by using also our extremely skilled helicopter pilot, David Okita, to actually fly along the edges of the flows, not directly on top of it for safety reasons, but offset by maybe 20 to 30 meters. Just fly along the edge of that and then have somebody recording in the ArcGIS collector app while the helicopter is flying along, input that data immediately into this cloud map in ArcGIS Online, which was immediately visible to me in the office and to Civil Defense. We were able to open up the sharing on this so that Civil Defense could see the data right away. They were really excited by this, and I think we're gonna be using this method a lot in the future. So during the Mauna Loa eruption, we, USGS, did not have our system set up to put our flow layers out to the public. But fortunately, Civil Defense did. And so it was visible to everybody there as soon as we were putting it in. But in the future, we should be able to, in addition to doing that, we should be able to host it on our own as well, which would also be replicated to the map on the HVO website, hosted in the exact same way that the historical flow polygons are hosted on the HVO website map right now. So it would just be another layer in that map that you could toggle on and off to see the most recent eruption data. One of the other tools, though, that I've also been working on, and we have been working on at the Hawaiian Volcano Observatory to further leveraging our webcam network. To help us do that a little bit better, we've developed these webcam overlays where we have specific landmarks pinpointed in the image and visible to us on our internal network. I'll give you an example of a situation where this would be super useful. I took a little bit of liberty with this next slide here of a semi-ridiculous depiction of what a lava flow might look like on this camera. With no landmarks in view there, it's very hard to pinpoint that. But you put the overlay back on from the daytime view, you see that the eruption has started at the summit, which is the typical pattern for Mauna Loa. But then as we progress here, we start having a fissure coming down to the southwest, but not so fast. That actually happened during the most recent eruption, where a fissure propagated just a little bit out the southwest side of the caldera and sent flows within just a couple kilometers of the vents. But it didn't go any further than that. It then reversed back to the northeast. And this is actually a pretty common pattern with Mauna Loa eruptions, that it kind of starts going to the southwest and then doubles back to the northeast rift zone. Same exact thing happened in 1984. So it's really, if the flows start propagating further down the southwest rift zone, like if they get to Sulphur Cone or this other location called Dandelion, where we have our M3 camera further out on the southwest rift zone, that's a good indication that it's a true southwest rift eruption, and we got to start thinking about taking action in South Kona. So just as an example of that, yeah, you're just my crazy drawing of a eruptive plume coming out there just downrift of Sulphur Cone. So that's an example of what we're looking at with like a true southwest rift zone eruption. And we could also turn this camera and follow the flows as they come down to the coast. This pan tilt zoom has a full 360-degree span of view, and you can even see like Milili'i and the coastline in South Kona and Kau from this camera. That's it. Thank you guys for coming. Yeah.
All right. So that was Mike Zoller, USGS HVO, talk at the Hawaii Lava Zone Museum. Any thoughts, Dane?
Yeah, that was one of the better speeches. Just there was so much juicy information for us, maybe, right? It might have been not the best for a layman because there was just a lot of stuff that was really interesting to me in terms of the mapping and being able to try and do that in real time and figuring out based upon web cameras, the positions of lava flows as they're happening. All that kind of stuff is right up my alley. So this was one of my favorite talks.
Yeah, I mean, in fact, we've done a lot of this stuff, right? Kind of working backwards, right? Like we actually, we did the same thing during Mauna Loa eruption. We had the time lapses that spanned day and night from the same fixed cameras, and we would draw on them and flip them back and forth. And we obviously weren't producing a map for publication by the government, so we could be a little bit more loose with it. But it was the same idea there, right? That was
right.
pretty much on it. So nice to see them take that next step to the overlays. And yeah, one part that I cut out is like there's a little challenging when the camera moves around. You have to figure out how to make the overlay match the right location. So that's why I don't make that public yet, but maybe someday I'll figure that out. Have a full like 360 overlay across the entire thing, and who knows? Yeah.
Yeah. There's a lot of potential out there that we've seen for years and hasn't really. It's just still being the beginning of getting tapped into what's possible. That was one of the cool things to me was when he was talking about accessing the government satellites to get polygons made. Like, sure, they won't give you the high definition satellite images, but is all you guys, if you can give us the polygons, that's all I care about anyways. And that's huge because I remember in 2018 trying to talk to ITDRC and being like, can Google get a satellite that can take like, is there anything from the private side that can be done even with heavy hitters at your side? And it was like, basically, no, you have to use these government type things and you have to have the access to them. And even USGS, and we don't have direct access to these things. Right.
But they have at least worked through the kinks, and now they have a pipeline. Once the satellite flies over, within 6 hours they can get the polygons. Now, all they have to do is update a layer in our GIS, and it propagates their map online.
Yep,
that's awesome. I can't wait to see it happen.
Yep.
Yeah. So and then actually this goes back to when I first began at the USGS HBO. So it's been a long time. 20 years ago, I made a map for the earthquakes, the first earthquake map to go online to show where the live earthquakes were. We had to do a lot of the mapping and figuring out how to make maps. And when I was not doing that, I was out doing that very time-intensive ground mapping lava flows, where I walk around the edge of the flow with a GPS and just take a point, and I love doing it. That was what I always would choose to do if I could, because you got to be hiking next to lava all the time, and that's how I learned about lava and how it flows and how it moves and what happens, and seeing it enough times, enough places to be like, oh, that was unusual, or this is rare, but now you've seen it happen, right? And that's part of my whole foundational thing. So when I first joined HVO, I remember I was just drawing things in by hand after flying a helicopter. That's when I was there. So it makes me feel old compared to Mike there, because he's like, that's before I was around. Like, okay, well, I was actually there for that, believe it or
not. Oh, that's funny.
But great to see the progress. That's really, really awesome, right? Like, when it's really shortly after an eruption, you get information out to the public as quickly as possible. You use anything you can. Like we did that in 2018. And great to see the USGS embracing that approach as well for Mauna Loa. And you saw how stuck they were the first couple of days with how much clouds there were. They kind of had no option, honestly, right? They had to do something. So great to see them work that out, and without any real significant human impact there, because in the future it might be a lot more important to have those maps out quickly if it's going towards people.
And I've said it before, I'll say it again, that Mauna Loa eruption was a great training run. It was the best training run you ever could have asked for. because it got into the rift zone. It did all the things, full eruption, the fear, the hype, all of it was there. And we got away basically scot-free, as scot-free as you can get on a rift zone eruption of Mauna Loa, right? A few little roads, that's so nothing. Yeah, it could easily be bad. And we wanted to, it was great just to get one under the belt, because it was 38 years before that. And nobody had really great practice, right? I remember at university, I was hearing Mauna Loa is going to do something. Mauna Loa, it was almost turning into like, look out, because it just hadn't happened in a lot of people's lifespans that were at the university, that it was thought of in this weird way, right? Now we've all gone through one, and I don't know. I think that's good.
Yeah, and fascinating that the mapping, like the mapping is so different, right? They couldn't use the drones, they couldn't use the satellites, they couldn't use on the ground walking around the flow, right? So they're forced to really up their game, and that was really impressive how they got something out of it in the end, and now they can use it going forward. Because even Kilauea, he says relatively easy, but that's because they actually did that LiDAR survey and got that data set in the first place, right? That was kind of the beginning of this whole modernization of data collection, HVO, as I like to think of it. Drones flew for the first time, in a national park to collect data for the USGS in 2019. They went and scooped water after that. They went and made maps after that. So it's a whole breakthrough. That's new, right? From when I was there, the revolution was, we now have a webcam. We don't have to actually walk out there and look with our own eyes. We can actually look at the camera and see it. So what another step up, and the progression is really, really awesome to see. I think the USGS really is a global leader in volcano monitoring and developing technique and methodology. And to kind of wrap it and tie it all together, great to see them collaborating with guys in Italy and elsewhere to make sure that even as everyone else is innovating as well, that all makes it back to Hawaii, and we can have the most complete and high-tech network of monitoring that we can, right? And as with us, the goal being ultimately public safety, better public safety, more information. And that's why we're sharing volcano awareness, so we can be better prepared for any disaster when it actually comes into neighborhoods in the future. It's just a matter of time before it happens again. Hopefully it's a long, long time, but we can't be ready soon enough.
Right. Yeah. So I think I've really enjoyed that presentation, and I think we do have one question if you want to get into that. Let's do something else you want to.
Let's see what we can discuss there.
So this is actually a question we've had somewhat often. So a question, just curious to know if Hawaii has a good evacuation plan if volcanoes happen during the middle of a hurricane season or no.
Yeah, it's interesting discussion to have there, right? Volcanoes get relatively few people, right? They're a fairly small, overall a fairly small area of impact, right? Even 2018, compare that to a hurricane. A hurricane's going to get everyone on that side of the island, right? And possibly the other side of the island as well, right? So a hurricane has a much bigger extent. An earthquake is likewise much more dangerous. Earthquake shakes everyone. Everyone lives on the ground mostly, right? The ground shakes, everyone's going to get it. Lava flows only go to a very specific part where it actually can reach from the fissure. So the broader question, right? How can we deal with multiple disasters at the same time? That's a whole other organizational and management issue that, we hopefully our approach is the better prepared we can be overall, the more we can handle, whether it's one really intense one or two at the same time or what have you. I don't think we're there yet. We still have a long way to go. I think Maui Lahaina fires last year showed us that overall as a state, we still have a long way to go. But I think we are on the right path, right? And I don't know if there's specifically if hurricanes and volcanoes together, but overall there's this plan, there's that plan, and they're set up in a way where hopefully we can mobilize enough people to deal with that if it were to happen simultaneously.
Right. It's also worth noting that we have seen that before. Like in 2018, we had the big lower east rift zone eruption happening. At the very end of it, a Category 5 Hurricane Lane, came and wrapped around the island. It didn't create the windfall, but it created all of the rain you could ever imagine. for a few days, and that created what we call whiteout conditions on the lava field, the new lava flows. It was so much steam that you can't see into it. I think somebody in the 3 days of the rains, one person from a helicopter managed to sneak a shot through all the steam just to see like a little trickle of orange. So we know like, okay, it's still there, but that's really all we got right now. Kind of flying a little blind because we can't see it anymore. And even the thermals are kind of hard to use with all that steam out there. So it's, but a lot of the evacuations had already happened for the lava flow. So you had the early evacuations a month prior for the lava flow, and then the hurricane came in because the lava flows last, weeks to months.
Right. And the flooding that occurred during that event was more in Hilo, in areas that have more of the streams and gullies and have older land that's more eroded and carries all that water, right? So it's a slightly different place. It certainly can happen together, right? There's old Hawaiian stories that flows come down the river banks as well, or down the riverbeds too. So but it could happen. We should prepare for it. The most likely double disaster is a earthquake tsunami. That happens, a local earthquake. Within minutes, you get a tsunami. And just like we talked about in 1868 the last couple of weeks, and it's hard to tell what got damaged from what sometimes. Was it the actual earthquake that knocked your house down, or was it the tsunami that washed it over? And sometimes you can't really tell if it's that long ago, right? And the other one would be double earthquakes, right? In 1868 we had a 7.9 followed by a 7.0 maybe, or 7.1, then a 7.9, and then a 7.0, all back to back. So that's another likely thing that could happen.
Yeah, the earthquakes are really where it starts to get really hazardous really quickly, like the speed and the unpredictability of it, because it's just like snap, you're in it. I hope you were in the right spot and you weren't in the shower or anything like that. You can just be wrong place, wrong time very easily on those. Where something like a tsunami from Alaska, okay, well now we have 6 hours or so,
right?
And we'll know about it. We'll have data on how big it is. We'll know its approximate arrival time. The tsunami sirens will go off. Evacuation routes will be opened. All that will be in place well before it arrives.
Yeah, and if it happens to Japan or Chile, you have even more time, 10 or 12 or 14 hours. So it's fitting that we talk about the tsunamis here, and as we still are in Tsunami Awareness Month too.
And next week, or on the, I'll just throw this out there. If you do live in Hilo, on the 27th of this month, out by Richardson's on the coastline there's going to be an opening up of an evacuation route, and that'll be the public will be allowed to access it between 9 and 10 a.m. to test out the new evacuation route. And it basically wraps from where Richardson's is and all the houses in there, wraps around the airport back out of that whole area. So it's a secondary route in case that one road gets compromised. So that'll be at Richardson's. They're staging a tsunami on Saturday as an evacuation drill and opening up everything so the community gets familiar. So if you live in that area, definitely check it out Saturday. It could, hate to say it, but it could save your life in the worst case scenario.
Yeah, we looked at the map last week, right? That the zone for Hilo, the safe zone, is all the way up by the airport. So that's the general idea: is get inland uphill as far as you can, as quickly as possible, and then start working your way around. And if you have to hang out by the airport fence, then so be it. Yeah.
But figured I'd throw that out there.
All right, yeah, good one. So I think that's it for this week. And unless something comes up unexpectedly, we'll be back next week at the same time. All right, Jeannie, anything else you want to add here?
I think that's it. If you're around Pahoa tomorrow, or on Saturday, stop by the Pahoa Community Center / Billy Canoe Park area, and the youth jam will be going on, the Brother Cuz Youth Jam. So lots of vendors, lots of people to talk to, get to see what all the different nonprofits are doing. So I think it's worth it. Check it out if you're on the east side.
Right on, Dane. Mahalo for that. So let's say our goodbyes here. All right. So, yeah, from HVERI, I'm Philip Ong, Dane DuPont. We'll be back with you at the same time next week unless something else happens. Mahalo to our ASL interpreters, Carrie and Dano. And to all you guys out there watching us live. We still got over 100 people here, an hour and a half in. All you guys on replay. So mahalo, you guys. Check out our outro coming up here. We ho until next week. Where's the button? Okay, here we go.